In today's lesson, we are going to be looking at rational exponents and radicals. So this is going to build off of the power laws we looked at in our previous lesson, and this will be something new that you haven't looked at in some of the previous years. So it's still going to carry over, still going to use the same power laws, we're still going to be dealing with exponents, but we're going to be looking at something slightly different. What we're going to be looking at today, as mentioned, is rational exponents and radicals. So what rational exponents are they are fractions. So when we have exponents as fractions, that is a rational exponent. A radical is, you've seen them before, it is the square root sign. However, the square root usually has a value of 2 in it. We don't really see it. It's kind of the implied value, kind of like if we don't see an exponent, we assume it's 1. Or if we don't see a coefficient in front of a letter, we assume it's 1. Same thing when we're dealing with radicals. If we don't see a number in front of it, we assume it's 2 for the square root. However, there can be different values that we look for. There can be different values available, or that can be on that root sign, right? So it could be the fourth or the cubed or the eighth root. It can vary. And there is a relationship between when we have an exponent as a fraction and a radical. And we see our first kind of example is when we have b to the power of 1 over a number, right? Or a fraction where it's just 1 over any number. That becomes a radical to the nth root, right? So the nth root of whatever the base is. So this value here would become 2. And on your calculator, you do have buttons that can do this. It would be something seen as like x with the root sign. So you would have to type in the number, then hit this button, and then whatever your b value is to figure out the nth root of your value. Now, in some cases, you may have to do shift or second function to find that, but you should have this button somewhere on your calculator. It should look something like that. Or in some cases, if it's not an X, it might be something that looks like a box in front of that root sign. So one of those two options you should see on your calculator when you're doing these types of questions or when you have to evaluate. So what we want to do is we want to evaluate the following radicals as a power with rational exponents and then evaluate. So I guess we should say the first one is our rational and then our second one is our radical. So when we talk about radicals, right, we're talking about ones with the roots. When we're talking about rational exponents or powers with rational exponents, we're talking about the fraction exponent. So it all depends on what we're trying to convert to or switch between. So here we have a radical and we want to rewrite it as a power with a rational exponent. So if this is the fourth root of 16, right, the 4 in front becomes 16 to the power of 1 over 4. I can actually evaluate this on my calculator and I can get 16 to the power of 1 divided by 4, and I can get 2. So if you're entering it on your calculator, depending on how strong your calculator is or how it likes you to enter things, you could write 16 to the power of 1 divided by 4, and that should give you your answer of 2. So make sure you are trying these on your calculator so you do understand how you can calculate these types of expressions. For the next one, we want to rewrite it again. So it's the sixth root of 729. So that means 729 to the power of 1 over 6. If I evaluate this, I should get 3. Which we do. Right, so again, make sure that you are comfortable entering these into your calculator. Now, a rational exponent may not just be 1 over a value. It might be an actual fraction. Right? So we might have something like b to the power of m over n. And if that's the case, the denominator still becomes the value of our root, but the numerator becomes or stays as a power or an exponent for that root. So both parts now are adding to two different, or both parts of our fraction are becoming two different parts of our radical. One's becoming the root and one is becoming the exponent. Right? The same thing would apply with when it's 1 over n, but when we raise anything to the power of 1, it doesn't really change anything. So that's why we didn't really see anything on the previous one. So again, we still have our rational form and we have our radical form. Now, in this case, we want to convert from the rational exponent to the radical form and then evaluate. So kind of going in the other direction. Now, you will be expected to be able to go back and forth between the different forms, similar to what we did in the last one, even if we had a radical with 2 values instead of the 1. So based on our kind of our rule or our transformation or our change from one form to another, this is going to become something. We're going to have my root sign with the base of 4. The value in front is going to be a 2, and then that entire thing is going to be cubed. So it's the second root of 4, or we can just call it the square root of 4 to the power of 3. So this is just the same thing as saying the square root when we have the 2. So if we have a 2, we don't necessarily need to show it. Right, so I could just write this as square root of 4 to the power of 3. That would be the same thing. So if I want to evaluate this now on my calculator, I would go through. If we wanted to, we can simplify the bracket first. So rather than doing a bunch of different things at once, I can simplify the bracket and say, okay, this is going to be 2 to the power of 3, because the square root of 4 is 2, and then 2 to the power of 3 is 8. You can also enter this into your calculator and evaluate it that way. For our next one, 23 to the power of 2/3. So in this case, this is going to say, okay, if I convert it, it's going to be the cubed root of 23 to the power of 2. So now this might not give us a nice value, because if we do the cubed root of 3, of 23, we don't get anything nice. But then when we square it, and we still don't get anything nice. But just to test out our calculators, we should get 8.0, we'll say 9 if we round it. Right, so again, just making sure that we are comfortable with our calculators when we're going through and evaluating. Now, with these power laws or with these rational exponents, we can still use our power laws in the same way. Right? It's just going to be now involving fractions as we deal through these types of questions. So it's the same types of rules or the same laws that we looked at in the previous lesson. Now we're just dealing with fractions in our exponents. So we're going to simplify and then write each as a positive exponent. So for the first one, right, we have a bunch of power to a power rules. So when we have a power to a power, that means we have to multiply. So 1 over 3 times 2. And for the second one, I can treat this separately, 5 times negative 3 over 6. So these two powers become separately x to the power of 2/3 times x to the power of negative 15 over 6. Now the rule states that when we are multiplying powers, we have to add our exponents. So this is going to become x to the power of 2 over 3 plus negative 15 over 6. So if we think about adding fractions, I'm going to do this off to the side. So 2 over 3 plus, or let's say minus, because plus and a minus become a negative, or minus 15 over 6. I can change the second fraction or reduce, or change the first fraction or reduce the second fraction, whichever way we see fit. I'm going to change the first fraction because we want to have a common denominator. So 2/3 is the same thing as 4 over 6. minus 15 over 6, and we get, when we subtract, we only subtract the numerators, so we get negative 11 over 6. So now our simplified power is x to the power of negative 11 over 6. This is just off to the side. But we want it as a positive exponent, so that means we have to flip our base, becomes 1 over x to the power of 11 over 6. So again, we're flipping the base, we're not flipping the exponent. The only thing we're doing with the exponent is changing the sign. We're also not changing anything with the base, so it's staying as x. Next one for B, we're going to go through and do similar things. First, when we have a power to a power, so we're going to multiply. So 1 over 4 times negative 2. For the denominator, there's nothing we can really do with that. It's only one exponent, or one power. So on the top, we get 3 to the power of negative 2 over 4, divided by 3 to the power of 5 over 12. And you can see how it's really important in these types of questions now to be neat with your work. Right? If you're not being neat with your work and it's very messy, then you can mix things up. Maybe the fraction looks like it's being multiplied and it's not a power, right, or an exponent, right? So we have to be really careful in that we're being neat and precise when we're writing out our questions or our solutions. So the next step is to subtract our exponents because we are dividing. So this is going to become 3 to the power of negative 2 over 4 minus 5 over 12. In order to subtract this, we need a common denominator. So if I take negative 2 over 4 and get it to a common denominator of 12, so that's the same thing as saying negative 6 over 12. Right? Or I just multiply both by 3. So negative 6 over 12 minus 5 over 12 becomes negative 11 over 12. So my exponent now goes from being the subtraction, and it comes out as 3 to the power of negative 11 over 12. Now you don't need to show this whole step separately. I'm doing that just so you see where we're getting this conversion from. So hopefully you are a little bit comfortable of working with fractions. If not, make sure you are using your calculator to help you with that. Now you do need to use leave your power or your exponent as a fraction, because that is going to be helpful when you're evaluating, right, for when you get an exact answer. So now I need to still write it as a positive exponent. So now I'm going to flip it over 1. So 1 over 3 to the power of 11 over 12. Right, we flip our base, make our exponent positive. And if I want to evaluate this, I could evaluate it as 3 to the power of 11 over 12, or I could write it as 1 over the 12th root of 3 to the power of 11. And this would roughly work out to, if I calculate this, 1 over 2.74 or 0.37. For the next one, I have a mixture of radicals and rational exponents. So because I'm dealing with power laws, I want to make sure that everything is written in a similar form. And our power laws work when we have exponents. So I need to convert this radical to a rational exponent, or to a power with a rational exponent. So our rule said that this value becomes the denominator, this value becomes the numerator. So this is the same thing as saying 16 to the power of 3 over 4. And that's going to be multiplied with 16 to the power of negative 1 over 4. When we're multiplying powers, we add them. So this becomes 16 to the power of 3 over 4 minus or plus negative 1 over 4. I already have common denominator, so I don't have to do anything else. So this becomes 16 to the power of 2 over 4. I can reduce that fraction. So even though it's in an exponent, I can still reduce it. So 16 to the power of a half. This becomes the square root of 16, or 2, the second root of 16 to the power of 1. I don't need to show this 2 here. I'm going to put it here just so we know where it went. And the square root of 16 is 4. We've gone through and we've evaluated it. We've reduced it to a single power and then evaluated. For our next one, b to the power of negative 3 over 8 to the power of 4 to the power of 2 over 3. So our power rules state that we're going to be multiplying, right? Power to a power to another power, we're going to be multiplying. So this is going to be the same thing as b to the power of negative 3 over 8 times 4 times 2 over 3. Now I'm going to do this step by step. I'm going to do this one at a time. So negative 3 over 8, I'm just going to do this at one at a time, times 4. When I multiply fractions, I multiply straight across. So this is negative 12 over 8. So this becomes b to the power of negative 12 over 8 times 2 over 3. I now still have to multiply these two powers together. So this became this value. And now the next one I'm going to do, just off to the side, negative 12 over 8 times 2 over 3, multiply straight across, we get negative 24 over 24. We get negative 24 over 24. Oops. For my new exponent. If we want, or not if we want to, we can reduce this to just b to the power of negative 1. If we want to rewrite it as a positive exponent, it becomes 1 over b to the power of 1, or just 1 over b. Right, so again, the main thing from this lesson is just understanding that we can have fractions in our exponents, understanding what that means between the radical form and the rational form, and as well as we can still use the same power laws that we've dealt with in our previous lesson with these rational exponents. Now, it may not be nice or as easy as some of the other ones because we are dealing with fractions, but it is a similar process. The same rules apply, just now with fractions instead of integers or whole numbers.